Good afternoon, everybody. My name is Charlie Johnston. I'm the CEO of Dukosi, based in Edinburgh. We're a team of 15 people, of which 11 are very talented engineers in the software, electronics, mechanical, and electrochemistry sectors. We have a global outreach in terms of marketing across all regions. We are working across all stakeholders in the supply chain, whether they be automotive OEMs, grid energy storage companies, mass transit, marine, and even aerospace, albeit that's going to take some time to develop. So what do? We work across all these sectors. Batteries are everywhere. I think we know that. We have a technology that makes batteries smart. We essentially, we've developed some software, and we are developing a chip to be installed on each and every battery cell within a battery pack. Our technology provides not just data, but it provides information. So what that means is it has the opportunity to eliminate some complex wiring, some electronics equipment, and simplify the master controller equipment within the battery management system. When we look at the demand for batteries, and this example is in the automotive sector, the market is huge, and it's important to scale up. And we have the capability through our manufacturing partners to scale up to the volumes necessary to support automotive and other markets concurrently. Our focus is currently in Asia with significant investment in capacity. Our technology contributes to that capacity increase by virtue of the data that can be provided during the manufacturing process. We provide a provenance of the cell, each and every cell that's manufactured. We're able to reduce the cycle times in the manufacturing process, increase the velocity, and thereby add capacity in the manufacturing facilities. We're also able to document each and every event log during manufacturing, storage, and in service, through to repurposing into a second life and to recycling. You can see that on the chart on the right that the increase of electric vehicles compared to internal combustion-driven vehicles, there's a substantial ramp-up. In fact, a Bloomberg report recently suggested that there will be 98 million electric vehicles in the fleet in 2030. If you take a Chevrolet Volt or a Nissan Leaf, there are 192 cells in each battery pack, and that represents close to 20 billion battery cells in the marketplace by 2030, with each cell having a Dukosi chip installed upon it. So when we look at the actual architecture of the battery cell itself, we have the chip that's installed on the cell or in the cell. We're developing some technology to embed the chip within a pouch cell currently. We have an embedded RF antenna. It is near-field wireless capability. We have patented wireless capability on this chip. We have a high-performance processor, and we have lots of memory to document the history of the cell and the events throughout the whole life cycle of the product. We also have a very simple twisted pair antenna that sits above each and every chip. And essentially what that does, it allows the system to be simpler in the context of eliminating all those high voltage wires that have to be isolated in an electric vehicle, for example, therefore contributing to safety. It also eliminates the slave electronics in an electric vehicle, of which there can be up to 8. In the Dukosi example, we have one interface unit that replaces up to 8 slave units. We also take a number of the electronic components out of the master controller, making it very simple, and the decision processes are flowed downstream to the Dukosi technology. In terms of the overall cost, we are estimating right now that we're at worst cost neutral. we believe that we can offer cost savings to our customers, especially when we scale up to grid energy storage systems that have thousands of cells and thousands of wires going in and out the installation. We have higher yields through process improvement, less waste. We can increase the velocity, as I mentioned in the shop. This is just a summary of some of the solutions we can provide with our technology. One of the items I did not mention is that at times these battery cells can be stored at the supplier warehouse for up to 1 year, and at the customer's warehouse for up to 2 years. So what we're obliged to do is to go and test those cells periodically to make sure that they're safe and the quality is still correct. With Dukosi technology, you can continuously monitor those cells during manufacturing, storage, transportation, in-service and recycling. And that's Dukosi, and we make batteries smart. Thank you.
Really, really cool. I think that's a very, very nice technological approach. So I have 2 questions. Do you have revenue, and are you fundraising?
Okay, that's a good question. We are funded by long-term investors, and we are about to go into a next funding round early next year. Okay.
And revenues?
And revenues are expected to commence 2020 with grid storage or energy storage solutions, and then moving into automotive with an ISO 26262 qualified device, and those revenues are anticipated to come in around 2022.
Okay, super. Thank you very much, Charlie.
Thank you, Jan. Thanks for the invite.